So if we look at honors geometry, that's you guys. Students will be able to, also you guys, will be able to use angle, angle, side, angle, and hypotenuse leg to prove triangles congruent. We have 3 more shortcuts we're going to learn today, which is section 5.5, the last section of this chapter, okay? So before break, in 5.4, okay, we just kind of recapped them a bit too. We learned side, SSS, and side, angle, side, SAS. We're going to learn 3 more today and how they work. So the first one is angle, side, angle, okay? So this is 2 congruent angles and the included sides. So 2 congruent angles and the included sides. So we have these pristine triangles here, okay? So we know we're going to have 2 congruent angles and we're going to have their included side, okay? So this is what we know right now. Okay, we know those things. So 2 angles and the included side, which included means that they're between them, okay? So just to double clarify. Now, obviously, like I kind of gave it away by telling you what it is already, but let's walk through this, though, and think, okay, is there any way you can have this set up and the triangles aren't congruent? Okay? Is there any way you can have this set up and the triangles aren't congruent? Like, is there any way we can modify a side or modify a point or anything like that? Let's say, like, okay, what if I put another point, instead of this triangle having a point here, we move it to over here. Okay? Well, that changes this angle, doesn't it? Okay? So, even though that would make it a different side length than this blue triangle, that would change the angle. Okay? Aiden, are you stretching? Okay, what are you thinking?
Start stretching again.
I was going to say that, like, lengthen out the other 2 sides, but I just realized...
What if, like, we extend the other 2 sides?
Yes.
Yeah, but if we extend the other 2 sides, yeah, and then...
Just make a bigger X.
And then it just makes kind of a bigger cross and a bigger intersection there.
Different.
What?
Now it's different.
Now it's different, but they're still the same triangle, right? I love that you brought that up, though, because it's good for us to start brainstorming this, okay? So if you actually have 2 angles and the included side, the side between them, there's no way that you can say these triangles aren't going to be congruent. So if you know that much about these 2 triangles, that's enough to say it. So that's our angle, side, angle, ASA triangles. And notice the S is located between the angles, which is very important because it's the side between the 2 included angles. So 2 angles and the included side, maybe even underline that word included, of one triangle are congruent to 2 angles and the included side of another triangle, then the triangles are congruent. So let's try and put this in practice a little bit. Let's make it a little more tangible here, okay? So on number 1, or excuse me, letter A, triangle ABC, triangle DEF, okay? Let's think about what do we have here to figure out what we have, whether or not we can say these triangles are congruent, okay? So we have to figure out what do we have. So what do we have here? What's something that we have between both of these triangles? Okay, Aiden.
61.
Okay, angle 60, the angle that's measured is 61 degrees, angle C and angle F, those are congruent, right? Okay, what's something else that we have, Kelly?
The 2.3 centimeters side on the base.
Yeah, side DF and side AC, those are both 2.3 centimeters, those are congruent, okay? And those are both are to the left of the angle that we've already said is congruent, right? That's important to note the location, okay? Aiden, what else are you thinking?
We can both find out. We can find out what B is and we also find out what B is.
Yeah, we can find out what measures of angle B and D are, and in fact, we have to, okay? So which one of those do we want to figure out first?
D.
Okay, let's figure out measure of angle D. So how do we find the measure of angle D?
180 minus 74 minus 61.
Okay, 180 minus both 74 and 61 will be whatever angle D is, okay? What did you say?
I think it's something with a 5 at the end.
Okay, it is something with a 5 out of the end. It's going to be 45. Okay, and now what do we notice?
It's the same on the other side.
It's the same as angle A, right? So those are congruent. Does that create angle, side, angle?
Yes.
2 angles and the included side, okay? Now, one thing I also like to do to help us kind of remember which letter combination you're using, if we kind of go along the triangle, angle, side, angle. So as you kind of go along, you say what you see next. Angle, side, angle, okay? It does match up, okay? Does that make sense?
Sure.
Okay, now, so that's enough to say that these triangles are congruent by this shortcut. So we can say triangle this is congruent to triangle this by something. Can anyone help me fill in kind of these blanks I left? Okay, triangle ABC, Jacob, keep going. Is congruent to triangle what?
DEF.
Okay, by what?
SAS.
Nope.
No.
ASA, angle side angle.
Awesome.
Asa, okay.
NASA without the N.
Yes, NASA with no N. Okay. Now, if we had found angle B to be 74 degrees, which it is, would we have been able to use angle B as part of our angle side angle? No. Kelly's shaking her head no. Why not, Kelly?
Because there's no outside.
There's no included side there, right? The side is a non-included side, so that wouldn't work. Okay. Question on that? Any of that problem? Okay, yes.
We can also use angle side, but we don't know that. And maybe HL, but I don't know what that is.
Okay, so maybe we could use another one of those, but we don't know them yet, so we're not quite sure. Okay, Bill?
Height, or is HL height length?
No.
Button is like.
Good job.
Okay,
Bill, you
yeah,
tried.
I said that earlier. And it's also for another, but good try, okay? Let's look at letter B, okay? Let's, once again, let's evaluate what do we have, okay? So when we're going through these triangle congruencies, I always want us to look at what do we have and start marking down information as quickly, or excuse me, as much information as possible, okay? Aiden, what's something we know?
The sides of 62 and 62.
Okay.
PM and JL.
Yeah, side PM and side JL, we know those are congruent, okay? What's something else that we know about these two triangles? Okay, let's go with Anna.
Oh, it has like J and M.
Yeah, angle J and M have the same measure, so those two angles are congruent, okay? What's something else? Do we know anything else right now? No, but can we find something else? Yeah, Kaya's saying yes. Kaya, what can we find? We can try and find the what? Angle P. We can find angle P, okay? We'll do that by taking 180, subtracting both 38 and 31.
Wait, that's so basic.
Okay?
If you add the 1 from 31 and the 8 from 8, it only makes up 9. And that is either going to be too big or too small.
Ooh, okay, so Aiden's predicting something early, saying, hey, we know that 38 and 31 is going to end in a 9. So that might make it not work because this ends in a 0 and this ends in a 1. So something look like it's not going to connect well. Okay, so let's see. Let's look forward and confirm or not whether that's true. So 180 subtracting 38 and subtracting 39, subtracting a total of 69. So you have 111. So are those the same?
They're not.
Okay, so can we definitively say whether or not these are congruent?
Yes.
Yeah, we can definitively say they're not congruent. We can say that for sure because we know those angles are not congruent. So you can say not congruent. Excuse me. And it says explain your reasoning. So you could say angle P is not congruent to angle L. You could say 110 does not equal 111. And let's say you found angle K to start instead of angle P. You could do the same thing. Angle K would not be congruent to angle N. Questions on that at all? Yes, Aiden.
Normally people don't put two correct things right next to each other.
Okay. Typically, one of those examples is probably going to be a non-example, right? Okay, let's look at letter C. Okay. What do we know here so far about these triangles? Now, how many triangles do we actually see?
2, 3.
3. We see the two individuals in the big one, but which two triangles are we probably going to be talking about?
The left and the one in the middle.
The two right triangles.
Okay. Triangle ABC and triangle ADC and triangle ABD, the two right triangles, one on the left, one on the right. Okay, however we want to word that. Okay, so what's something we know about these two triangles, Saren? Okay, we know they're both right. They're both correct. Okay, they're both right triangles. They both have an equal measure, right?
Yes.
Okay. What's something else we know? Okay, Aiden. Okay. Bill.
They have ASA.
Okay, you know already they have angle side angle.
Yep.
Okay, because they both have these congruent angles and this congruent side in the middle. They both already have angle side angle, don't they? So can somebody give me a congruent segment? Triangle this, congruent triangle this by Bill?
Triangle triangle ABD is congruent to triangle ACD by ASA.
Very good, very good. That would work.
Wait, what?
Triangle ABD is going to triangle ABD, ACD by angle side angle. Now, fun fact, there's actually another way we could prove these triangles congruent besides the angle side angle that we already know. Saren, what are you thinking?
Because they're both right and they're made in the same triangle.
Sorry, say that again.
Because they're both right and they both have two angles on the sides, so you don't even need to divide there.
So they could be equal out.
Please choose.
Not equilateral. Saren, I'm not sure I'm connecting with what you're saying.
Middle
Equal
angle
lengths.
is 90 degrees, definitively.
This,
And
yep.
Two angles on the sides, they're both
Yep.
due to the sides, so they would be equal.
So what would be these angles?
Those angles would be equal.
These angles? Yep, these angles are congruent. Does that help us do anything else yet, though?
That'd be angle, angle, angle.
That'd be angle, angle. That's not one of them yet, though, or maybe even at all. Not at all. Okay. So that we do know, though, that in fact that those are congruent. Okay, Max.
You know that the center line is itself.
The center line is congruent to itself. AD is congruent to AD. So now, could we use another method? Side, angle, side. Side, angle, side. Okay. We could also actually use another one. Anyone know another one we could use? Yeah.
Okay, I have two. Angle, angle, side.
Okay, we don't know it, so we can't use it if we don't know it. Okay, Bill? How do we know? So we don't know these other sides yet.
I don't know.
Okay.
You already know that's the only one I know.
Okay, we're just saying that's the other one. What? Okay, Saren?
Because the two angles on top and the two angles above are equal. Well, two on top equal, two above equal, so the sides would be equal.
What?
So if we look at this as a big triangle, we can know this is an isosceles triangle how?
Same basis.
Because the base angles are congruent. So that would tell us that these two sides are congruent. So now could we use side, side, side as well?
Yes.
Yeah, so some of these
That's right.
you can actually, yes, some of these you can actually use multiple methods to prove them. Okay? So just make sure that as you walk through it, you're supporting your work, you're supporting your answer with the accurate information on there. That's the kind of stuff you're going to have on your test to say, hey, make sure you mark down the right information. Because there might be some, hint, hint, where you can go through it a couple different ways. So I want to see your information and know that, hey, you actually went through this the proper way. That make sense? Alrighty, let's continue on. What? What did I do?
Everything.
My goodness, Mr. Costle. What is this, amateur hour? Oh, we have a lot more on there. Oh, we're going to skip those examples. I don't want them right now.
Yeah.
No, thank you.
Get that out of here.
Actually, let's do letter B. Let's do letter B. I changed my mind. We'll do letter B out of all of them. We'll do letter B.
Go back.
Okay. So we're given that angle A is equal to angle C and E is the midpoint of segment AC. Let's mark some information we know. What's information we know from that given information? Okay, we know angle A is equal to angle C, so let's draw an arc, okay? What's something else that we can know right now, okay? Saren?
That the two angles in the middle would be
Okay. So angle AEB and angle DEC? Okay, why are those congruent?
because these two A and C would be congruent, which are leading to
That doesn't necessarily, that doesn't impact it, okay? Aiden?
Get one thing for that is vertical angles. And
They're vertical angles, okay? Well, hold up. They're vertical angles, and vertical angles are always congruent. Okay, go ahead, Aiden.
AE, and since E is the midpoint, it cuts in half, so AE is going to go to EC.
Okay, AE is the midpoint of AC, so it means it cuts it in half, like you said. So AE is congruent to angle or side EC.
Now I can use NASA without the angle.
Yeah, now we can use NASA without the end. Angle, side angle. Any questions on how we got here with all of this? Okay, so we did prove that triangle AEB is congruent to triangle CED by angle, side angle.
You should do like as a.
Asa? Asa. I Asa. Okay? NASA without the N. Asia without the I. ASAP without the P. Okay. Anyway, Garfield. Anyway, as soon as. Okay. This one's a fun one. We won't do it right now. Okay. What? I never reuse problems that we don't do as warm-ups. I wouldn't do that.
Not at all. That's impossible.
Not me. Okay. Kelly, why'd you have to tell everyone that? Man, I had this nice thing going where, like, nobody said anything about... No, I'm just kidding. Okay. Angle, side, or angle, side, okay? So, let's go back to these little pictures I have. How beautiful they are.
Those are great.
My goodness, honestly, it just doesn't get better.
No.
Never. Oh, that's so much better.
Okay, so these triangles, we'll say that we have two angles and a non-included side, a side that's not included between the two. Is there a way we can make this to where they're not congruent, or is there something that even more we can do to say, oh, they actually are congruent? Bill.
They are congruent because, like those two, like if you do 180 and then minus those two, it should equal the other one.
Okay.
Once those are both congruent, then it has to.
So our third angles have to be congruent. Is that what you're saying?
Yes.
Okay, we actually had this theorem, third angles theorem, saying, hey, if two sets of corresponding angles are congruent, the third angles have to be congruent. Because if we add up whatever these measures happen to be and subtract from 180, we're going to get the same number both times. So now, could we just use angle side angle again?
Yep.
Yeah. Okay, Saren, what were you going to say?
I was gonna say the two little two one across from it, that wall would have to be equal to the other one
Not necessarily.
because the angle would change it.
So that's not necessarily true, and we'll actually see that today. Well, that's not necessarily true. Okay. Yes, Aiden.
What it's supposed to be is angle, side, but we beat you at that and made it not so without that.
Yeah, so we actually can transform this two angles in the non-included side into angle side angle. Okay, which then leads us to say, well, if we have two angles and a non-included side of one triangle congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. So not only do we need, so we don't actually just need a side between the two angles, we can actually have the side wherever we want, as long as they're corresponding. Does that make sense?
Sure, I don't know. Sure.
Okay, hopefully, maybe. Okay, Bueller, anyone? Bueller? Anyone get that reference?
Yeah.
Okay. Ferris Bueller's Day Off. It's a banger.
Liam.
All right. Oh, it is a good movie. Good movie. Lots of language, but good movie.
Oh yeah.
Okay.
Well, don't all movies at least have one language so they can actually hear themselves speaking?
He's saying like one language, not like languages in a swear, but languages in like spoken word. So, given that side AC or segment AC is congruent to segment EC, so we're told that these are congruent, so we can mark that.
And then wonderful angle theorem.
And we're told that line M is parallel with line N. Ooh, parallel lines. We got parallel lines again. Okay. Ooh, parallel lines again. Okay. Is there any more information we can use, because that's not enough right now, to figure out and prove that these two triangles are congruent?
Proofs.
Okay, someone other than Aiden. Aiden's been kind of loving this today, but I want to kind of spread the love. Dominic?
Vertical angle.
Okay, vertical angles. What two angles would be congruent by the vertical angles theorem?
C.
Like these? That's what you're talking about?
No, the other way.
Oh, okay, these?
Yeah. No, what I'm talking about up to down.
Oh, okay, but what are they called? Angle what, and angle what?
ACB.
Okay, angle ACB and angle DCE, right? Or ECD, okay? 3 letters, vertex in the middle, okay? So those are congruent by the vertical angles theorem, okay? Is that enough now? One pair of angles and one pair of sides?
Nope.
No. We have 3 letters, okay? So we need to get to 3 different parts, okay? So we need, in order to do angle, side, we would need one other angle, right? Okay, Jacob?
So if we do go back to the vertical angles theorem, you could use BCE and DCA, because those are another pair of angles.
BCE. Yeah, so you could say that those are congruent by the vertical angles theorem. That is factual. I don't think it helps us, but it is factual.
No, it's just another pair of angles.
That's another pair of angles. Yep. Are they another pair of angles in the triangles?
No.
Darn it. But it is another pair of angles, so I like that we're brainstorming and thinking about those things. Okay. Sarah, what are you thinking?
Because the angles BEC and ACB are congruent, then because of the congruent wall, they're angles BEC and CAB.
So we don't know that for certain yet. We don't know that for certain for that reason. We might be able to find that for a different reason, but we don't know for that reason. Kaya.
Aren't angle A and angle B from alternate interior?
Angle A and angle what?
E?
Angle A and angle E are alternate interior angles. Very good. So we take these two parallel lines and cut by this transversal. Angle A, angle CAB, and angle E, angle DEC are alternate interior angles. Okay? They alternate sides of the transversals. One's on the left, one's on the right. And they're both interior. There's two parallel lines. So what do you know about alternate interior angles when those lines are parallel? They're congruent. So we know those two angles are congruent. So now could we use angle side angle? Okay, could we do the same thing with alternate interior angles and say angle D and angle B? Yeah, so could we use either alternate interior angles or ASA or AAS? Yeah. Fun fact, whenever you have AAS, you can always use ASA. Whenever you have angle side, you could always use angle side angle, just like how we transformed it earlier by saying, oh, third angles theorem.
Does that work
But we
the
should
other way?
always do math.
No. Well, yes. It does work the other way, yeah. So if you can use one, you can always use the other as long as you mark the appropriate information. Because if you know two angles, you can always find the third angle. Triangle ABC is congruent to triangle EDC. What method do you want to use, Sierra? Front Sierra, not back Sierra.
AS.
ASA? Okay. Angle side angle. Is that what you said? Oh, okay.
Yeah.
I had another one of those moments where I thought you were wearing denim socks. I'm like, no, not denim socks. Okay. Any question on this one? See, no, I don't see any Y's on this one, buddy. Okay.
Are you sure?
Let's look at number 2.
Not mine.
If we're given that angle A is equal to angle D, is this enough? Can we find more information here?
Yes, counting. Still counting.
Counting, we can do the sides. Okay. Yes.
Well, you count and then angle B and angle
Angle B and angle B are both right angles. We can tell that by the graph.
then you can find F.
Then you can find F to know that those are congruent by the third angles theorem.
And then you can count the sides.
Yep.
B to A and B to E.
Okay. B to A and D to E are both what? 4. Is that enough information right there?
Yes.
Yeah.
Could we keep going and count B, C, and E, F?
Good.
Sure, you don't have to. Could you even do the distance formula to figure out CA and DF or Pythagorean theorem, even though we technically haven't learned it yet, but most of you probably know it? Yeah, we totally could. Okay, and you can figure out that these are actually 5 as well. So could we prove these triangles congruent by like any method we want? Sure. So triangle ABC is congruent to triangle DEF by literally any method that we've used so far. Anna, what method do you want to use? Cool. We'll use angle side angle.
No, so it's opposite.
Angle side angle seems to be the
No,
fan
so it's
favorite.
opposite.
Seems to be what? A fan favorite. It does. It does seem to be a fan favorite. Yes, yes. 2 out of 2 people suggest. Okay. Continuing on, if you don't have any questions. Okay, we're gonna skip. We're gonna skip number 3. Okay. Let's go on to our last one. Okay. Hypotenuse leg. Okay. But what's it say?
Only for right angle.
Well, only for a right triangle. Why might it only be for a right triangle?
A squared, B squared, C squared. Because you can't use the distance formula or whatever the other formula was unless it's a right angle.
Yeah, what Jacob
Because
said.
you can
Math.
science.
Aha.
None of these reasons are the ones I'm looking for.
No hypotenuse.
Say that again, Max.
There's no hypotenuse in the other one.
There's no hypotenuse in other triangles. Can you use something that's not there in another triangle?
Sure.
No. If the triangle doesn't have a hypotenuse, you can't use hypotenuse leg. So it's the only way it works for right triangles is because you have a hypotenuse, and the other two sides are called legs. So in a right triangle, if you have the hypotenuse and a leg of one right triangle, congruent to the hypotenuse and a leg of another right triangle, the triangles have to be congruent. So if you have the hypotenuse and a leg, you're Gucci. Okay? Hypotenuse and leg, you're Gucci, okay? And fun fact on this one, guys. If you know the hypotenuse and a leg, you know an angle as well because they're already right angles. Okay? You know an angle as well. But that's actually not one of them. Plot twist. Side-side angle actually doesn't work. I think we went over that the other day.
Use SSA. That's what it says.
Yes. You can't use it because it actually doesn't work. Technically, the only time it works is on this, but we just shortcut out the angle and say hypotenuse leg because it's quicker. Okay? Yes, Aiden.
But how do you know when you found a hypotenuse?
So you only have a hypotenuse when it's the right triangle. And which one of the three sides is the hypotenuse every time?
The curved one, the one that's not straight.
The long one.
Okay, it's always the longest one. Okay, and where is it located?
The other side, right? Angle.
Yeah, opposite the right angle. It kind of looks like the right angle's pointing at it.
But then why can't we just do the curved one and just call this the hypotenuse?
Because it doesn't want to, Aiden.
Because that's not a right angle.
Yeah, but why does it have to be right angle?
That's how hypotenuse is defined.
But why don't we just?
That's like saying, why is this red? Well, because we defined it as red.
Then why don't we just make up another word and call?
I mean, I suppose you could, but I'm not going to respect that word here. And you know, if you use it, I'll just count it wrong. So yes. So determine whether triangles are congruent and explain your reasoning. So on letter A, we kind of look like we have how many triangles here? 5.
Nailed it.
17.
There's 3 individuals, and you can kind of combine them and make 5. Okay, woo, a lot going on.
But you guessed.
Wait, what?
Yeah, I see it. Oh, I see it.
Okay, raise your hand if you don't see it yet. I'll show it to you if you don't. Okay. All right.
No one's
So
looking at you.
What?
okay. So we're trying to determine whether these triangles are congruent. What kind of triangles do we have these? Right triangles. And we're actually talking about these 2 big triangles right now, the ones that we have, the ones that I was asking if everyone saw. Those are actually the 2 we're talking about. Do we have enough information to say those triangles are congruent?
Sure, I have no idea. I don't think so.
We have.
We know they're both
And the
we
side.
know they're both right triangles, right? And we know we have a leg of each. Remember, the legs are the ones touching the right angle.
So we do.
Do we know the hypotenuse are congruent?
Yeah.
Well,
Yeah.
WX is the same thing.
Yeah.
WX is congruent to itself, right? It's congruent to itself, so now do we know the hypotenuse is congruent to the hypotenuse? Yeah, so now do we have enough information?
Yeah.
Yeah. So you can say triangle. Who wants to name these triangles? Triangle blank, blank, blank.
James.
All right. That's pretty good. That's pretty good.
Peter.
Okay. Yes, Kelly.
Triangle BWX congruent to triangle
The
Y.
triangle VWX congruent to triangle Y. I'm going to disagree. If we do our first one as VWX, we can't do YWX.
Why not?
Because the first 2 letters, VW, Volkswagen, okay, is the congruent leg. But YW is not the same leg. It's not corresponding, okay? Bill, what would we do instead?
It's YXW.
It'd be YXW. By HL, hypotenuse leg.
Wait, can you also use
No, it should say so. No, Aiden.
No.
Nope, we can't use SSA because it's not one.
Stop thinking.
Literally doesn't exist. Stop thinking. No, don't stop thinking. Okay?
Yeah, 3 questions per class.
Okay, questions on that?
Why?
Okay, we're going to skip letter B.
Woo!
Why? Because I want to. Okay, so we can prove using a lot of different methods. Here are the 5 methods we have. Side, angle, side, angle, slide, HL. Whew, that's a lot. Okay, lots to remember. Okay, here are the 2 you can't use. Literally the only 2 combinations you can't use. Angle, and that should say
It says you may use it, but it also says you may not use it.
side, angle. I mistyped that.
On here.
My apologies. On yours is correct. On mine, it's how did that happen? Anyway, okay. On mine, it's wrong up here, but on yours, it's correct. Okay, you can't use side angle, but you can use angle side, or angle.
Oh.
Okay. Now here's the way I help remember this. Okay. All the others involve some sort of sides, right?
Yes.
So that's why we can't do angle. Might be a good way to think about it. Okay. I'll also explain that one a little more in depth. Here, if we flip this around, that's a naughty word. Can't use naughty words in here.
That is true.
Can't use it. Now, it's not the reason it doesn't work. It actually just doesn't work. But it's quite convenient for math teachers. Okay, then I don't have to monitor the usage of that word. Okay, so the other way is saying, Mr. Costle, I'm just doing triangle congruence. I'm not saying a bad word. Okay, nope, can't have that. Doesn't even work. Okay, so get that out of here. Okay, here's why we can't do angle. Let's say we have these.
That's amazing.
Let's say we have these triangles, and they have their angles congruent. That's perfectly possible for them to have their angles congruent, but do these triangles look congruent at all? No, one's way bigger than the other. So they could have corresponding congruent angles and still not be congruent sides. So Saren, that's why the whole opposite side thing being the same length doesn't entirely work across triangles. It works when you're inside of the same triangle. Like let's say, for example, those are congruent. Then you could do the opposite ones of those. So it works inside of one triangle, but doesn't work across triangles. Does that make any more sense, Aaron?
Why I was saying is because they're congruent walls, so.
Yeah, but we didn't know those were congruent for that reason. So I'm trying to explain right now why that wouldn't work and why that's not true. Okay, maybe we'll talk about it more later, okay? So we can actually walk through these and prove them using any method as long as we know them, okay? So on this first triangle, is it possible to prove these two triangles are congruent by using any of the theorems? And if so, state it. Which one you could use?
No, because you cannot find out any side.
No, because you don't know any sides. Okay, so no.
No, because no sides.
And there's no sides, okay? You can say no, there's no angle, or there's no sides, or there's blah, 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 blah.
There ain't no sides.
Ain't no sides. Ain't no mountain high enough, okay? Could we prove the triangle is congruent on number 2?
Yes.
The middle one. Okay, how so?
Those NL.
Okay, NL is congruent to itself, so that's one set of angles and one set of sides.
And those two are parallel.
And we have parallel lines.
So,
So that means that
It's a box.
the other angle L and the other angle N
Okay, because those are alternate interior angles, right? So now we could use angle side angle, right?
that's without the N. Thank you.
Okay.
You can say-
You could also say, third angles theorem, and use angle side if you really want. Okay. You could also say third angles theorem. Those have to be congruent. Angle side now. Okay.
Wait.
This last one's kind of weird.
Stop. I died.
Okay. You have a lot going on there, right?
How many triangles are there?
Side.
Five.
Okay.
Three.
Oh,
And then-
five.
I want to see five. I want to see five.
So let's look at the two big triangles here.
You have each side and this side.
Wait. This is life with this thing right now. How many triangles are there?
There's 5.
How? No.
No, excuse me. There's only 3 on this one.
Thank you.
Excuse me.
What?
Hi guys.
Hi.
Hey, Debbie.
Hello.
We don't
Aw.
like you.
Straight us.
Can't you say we don't love you anymore?
Yeah.
So, here we know the bottom sides are congruent. We know the bottom sides are congruent. We know these sides are marked congruent, and we know these angles are congruent. Is that enough to say side angle side?
Maybe. I don't know. I haven't thought about it.
You haven't thought about it. Well, think about it. Okay. We got a lot going on here, don't we? Okay. Question on that.
Why? Wait, what?
I'm a jerk.
No, he's gonna put S-A.
Okay. This last part is just a little reference sheet and showing examples of what works, what doesn't. And so it has different things highlighted in the triangles of showing, hey, here are the methods that work. And then as well as hypotenuse leg. Okay. Questions on that? Okay, we're going to skip those last little examples. Okay, we're just going to skip them. Yep.
Time.
That's done.
What's the other thing? You said